So here's my solution for problem 13.3 as listed in the lecture PowerPoint. Essentially, it asks you to consider two bars, 1 and 2. F1 and F2 are the magnitudes of the tensile forces. They're undergoing a uniaxial tension test. E1 and E2 are the elastic moduli, and then A1 and A2 are the cross-sectional areas that are perpendicular to the applied forces. So it gives us these two problems and asks to indicate for the stress and strain, tensile stress and strain, which one is greater, equal to, or less than. So for this problem, I have written out essentially what the question asks up here, considering two bars, uniaxial tension test, F1 and F2 being the magnitude of tensile forces, E1 and E2 elastic moduli, A1 and A2 being the cross-sectional area. And we are being asked to determine the correct relationship for tensile stress and tensile strain under the given conditions. So if area 1 is greater than area 2 and the forces are equal, then what are these relationships? So we know that tensile stress is equal to force over area. So I've written this out for material 1 and material 2. If the forces are equal and then A1 is greater than A2, we can assume that F1 is equal to F2 is equal to 1, right? Because they are the same, they're equal to each other. And then I ask you to assume that A1 is equal to 2 and A2 is equal to 1 because we know A1 is greater than A2. So these are just filler values to demonstrate the process. When plugged back into the equation, we get that the tensile stress of the first material is 1 over 2, and the second material is 1 over 1, being 1. So the relationship ends up being that stress of 1 is less than the tensile stress of 2. Now for the strain is equal to stress over the elastic modulus. And so we know, given this, we know that the stress of material 1 is 1/2, the stress of material 2 is 1. So I plug this into the equation. We get that strain 1 is equal to 1 over 2 E1, and then strain 2 is equal to 1 over E2 because we have 1/2 and then 1 over 1, just like right here. So we are assuming that the elastic moduli are equal because it wasn't defined in the problem, and assuming that strain is equal to 1/2 and strain of material 1 is equal to 1/2 and strain of material 2 is equal to 1. So the strain of 1 is less than the strain of 2. For part B, we have assuming that elastic modulus of 1 is greater than 2, and then the areas and forces are the same. So I write down the same equation here for tensile stress, but since everything is equal, then stress 1 is equal to stress 2, because F and A of both are equal to each other as written here. Now for the second part, the elastic modulus of 1 is greater than the elastic modulus of 2. So we take elastic modulus of 1 to be 2 and elastic modulus of 2 to be 1. So we get stress over 2 is equal to strain 1, and then strain 2 is stress of 2 over 1. And since stress 1 and stress 2 are equal to each other, as defined right here, we get that strain 1 is less than strain 2, because this is essentially 1/2, whereas this would be 1 over 1. So this is being divided by 2, that's only being divided by 1. So that is where we end this relationship.